Hi, my name's Larry Fortna, and in this video I'm going to show you my 3D printer and how to use Simplify 3D to create two-color prints. Um, I have my iPhone set up here on and I'm using a Mac computer for this demonstration, and I'm using a program called Reflector to show my iPhone screen because I'm going to use it as the camera. So as we get started here, my printer is over to the left here, so you'll see me looking over here frequently. Um, right now um, I have a sheet of paper which I folded in half that I'm going to use to show you how to set up your bed leveling. Um, but before we get into all that, let me tell you a little bit about this 3D printer. This is a very inexpensive printer. It's $229 from the manufacturer who's now not manufacturing them anymore, but this is an acrylic unit, and I've made a few modifications to the original unit. It came with an aluminum bed, aluminum heat bed, which didn't work very well. So I changed that out and put a new hot bed on it, and I also put a sheet of glass borsalite on it, and on top of that I have a sheet of PEI. PEI is a material that allows you to print um, with less heat and get your filament to stick to the bed without using glue sticks and hairspray and all of this kind of stuff that you will see on the forums because people have trouble getting their filament to stick. PEI is an excellent product. I've been using this for over a year, still on the same sheet of PEI. I clean it up periodically with a little alcohol, and I have some real super fine sanding pads that are like 4,000 to 6,000 grit, which I can clean it up with. Okay, that said, um, this was an acrylic printer, and I keep it it's stabilized because I have it on a sheet of 3/4 inch MDF that you'll see here. Now this MDF is a very flat piece of material, and I've printed some hold downs um, to keep the 3D printer from moving around. And these are just glued onto the MDF, and then the 3D printer sits on top of that. So I've got hold downs back here, and I've got hold downs over here. And they're not really hold downs, they're just keeping it from shifting, from moving. Other than that, it was stock from the printer that was sent. And I did find one other thing, which we'll talk about just briefly here. Uses an Arduino circuit board along with a Ramps 1.4 motherboard, which controls the stepper motors and such, and the heat bed. And what I found with these boards is they use a crimp style connector for the heat bed connector, and it builds up a high resistance because there's a lot of current drawn through there. And I've actually melted the plastic on one of these connectors, and I have now soldered the heat bed directly to the back side of the board where the connector is on the Ramps board. And what this has done is allows the heat bed to heat up much faster, and I don't get that heat buildup, and so it's safer. I don't have a risk of the um, thing catching on fire. So this extruder is the MK7 model, and I just modified it a little bit to put a fan on here with it's held in place by 2 screws, and I have a connector which I can release, and I can take those two screws out, and this heat sink and the fan come off, and I can easily get inside to do anything I need to do to the extruder. Now, the most important part that I added to this 3D printer is right over here. And basically I just took this white piece here that came with it, and it used to go on this shaft, and I drilled a hole in it, and I moved it over here so that I could put my limit switch right under this piece here, which I printed on my 3D printer. And this screw in here is a 3mm fine thread screw, which allows me to do a very fine adjustment of the Z-axis. Now, what happens when you heat up the heat bed is these little springs over here, they heat up so they expand and they contract. And when they heat up, they expand and they bring the bed up more towards the extruder. So when you're adjusting your bed, it's best to do this while the heat bed is at the temperature you're going to be printing. I see that, along the forums, there's a lot of folks using these automatic height adjustments. That is not needed, folks. It's not needed at all. You need to spend just a little bit of time to make sure that all four corners of your heat bed are at the same height. And once you've done that, all you need to do now is to change the relative height of the bed when the bed is up to temperature. So I'm just going to kind of show you how my bed can drag this sheet of paper all around this around the bed, and it's just lightly touching the tip as I just barely move this sheet around, and once this is locked into place, the only adjustment you need to do from there on is to get your bed up to temperature and do a fine adjustment here. So you zero your Z-axis so that it fits, so that the a sheet of paper which is 0.2 of a millimeter in thickness, and it's just so that just fits under the nozzle. Now this assumes that you're printing at 0.2 of a millimeter. I print at 0.3 of a millimeter, which is okay. That's just going to give it a little more solid adhesion. Something to be observed here on my 3D printer, when I put the heat bed on here, I put some cork. This is 1/4-inch cork that sits underneath the heat bed between it and this acrylic travel acrylic that holds the rails and the bearings and such. And I put the cork in there to keep the heat from transferring to the acrylic, which will warp it and cause you problems. So that's something you might want to do in your 3D printer. The only other thing I found with this particular model was this Y-axis belt tensioner. It was on a spring, and it went side to side, and the belt would jump off the center of the bearings and would fray the belt. So I again 3D printed some supports that I can adjust right here and here, and I got it centered now so that it stays in place, and that gives me a nice Y-axis movement. A couple of things to consider when you're zeroing your bed, and that is to use a bubble level. And I have an application on my iPhone called AppZilla that has a bubble level that reads out hundredths of a degree on the bubble. So you can, I put my iPhone on the bed here. I get the reading, which should be very, whatever whatever is the levelness of the bed of the MDF is here. And then I make sure that when I put the bubble level up here on this rod here, and these two should be the same or very, very, very close to the same, so that when you adjust the you can adjust the either side of your Z-axis by turning these stepper motors. And you want to make sure that this piece here is level with this piece. And then go through and do the four corners and then double check your center. Once you've got all that set up, the next step is just to heat your bed up to operating temperature, zero your Z-axis, and adjust this screw so that this piece of paper fits in it just like this. This is extremely loose. It's just barely touching the nozzle. Okay. Now, with all of that said, let's go look at, I'm using Repetier host here. I also use Repetier server most of the time, but Repetier host to actually do the 3D printing. I don't use Simplify 3D for that. Just my preference. This particular app, if you will, program is for the Mac, and they also make one for the Windows. It looks a little different on Windows, but they have all the same settings. And so this is what I'm going to actually print with. But what I really wanted to get in to show you is Simplify 3D, which is a piece of software that generates the G-code for Repetier host. And I'm going to we're going to print this little arrow that I have on my Z-axis adjustment. And if you'll notice, my Z-axis adjustment disc had two colors in it. So we want the arrow to be a different color than the rest of the base part of it. So I want to go through the settings that I use on my Simplify 3D and share with you some of the tips and things that I have run across over the past year that make my prints come out very well. And some of these things I discovered quite by accident. And I'm going to talk about that as we examine all these different settings. So to start out with, let's go to the settings panel. And I've just named this first layer base layer. And because I'm using PLA, I have a particular setting set up here also for how much my infill is going to be, which I've set to 55%, and I think that works pretty well. For the extruder, I've named this extruder tool 0, and this is going to be important when we come to doing two-color prints, because I'm going to give you a different tool number for the second layer that we're going to create. But let's just kind of go through these settings real quick. I've set my retraction to 1.6 millimeters. This helps to produce or to prevent blobs from appearing whenever the layer height changes. I have my nozzle diameter is 0.40, and my extrusion multiplier is I've set to 0.95 only because I don't think I have my extruder calibrated exactly, and it also depends on what filament you're using, but I reduced that just a little bit. So if we go over to the next tab over here, we have the layer tab, and as you see, I'm going to set my printer height to 0.3 millimeters, and I'm going to do 4 outline perimeter shells, and I'm going to do 3 top and bottom layers. And I'm going to start my first layer speed at 60%. And the speed that we're going to use is going to be set in this in another tab over here. and that tab is the Other tab. So this is something that I discovered quite by accident, and I used to print at 3,600 millimeters per minute, and by mistake I had my speed set in Repetier to 200%, and I discovered that I could print at 7,200, and I was printing large parts, larger than the part that we're going to print here today, but I'm going to go ahead and leave this at 7,200 today just to show you how it can actually print at this speed. I've set my z-axis to, or my x and y axis rather, to 8,000 millimeters per minute, and my z-axis to 1,000. And my filament I'm using is 1.75. And it's a good idea to actually measure your filament and see exactly what it is with a caliper. And if it's a little undersized or oversized, then you can change that right here in Simplify 3D. Okay, let's go continuing on. We were back on the Layer tab. I think we're probably pretty much finished with that. As far as additions goes, I'm just going to do, I'm printing a small part here, and I'm going to leave the speed up at 7,200. So for that reason, I'm going to print a couple of skirt outlines to get the filament started before it actually has to start doing the part itself. For infill, because this is the base layer, I think I just might change this to concentric because it's a circle that I'm printing. And for my infill pattern, I think we'll change that to a fast honeycomb. I've set my interior fill percentage to 55, my outline overlap to 45%, and my extrusion width to 100%. So those all look good. This particular part doesn't need any support, so we're not going to do anything with that. But let's talk about the temperature. My heated bed for PLA is set at 60 degrees centigrade, and that is more than enough for PLA. For the primary extruder temperature, normally PLA, I would set this at 195 degrees. But what I have discovered is that if you're printing at the speeds of 7,200 millimeters per minute, you need to have that temperature up there. It needs to be hotter so that it can continue to flow at those speeds. So the other thing that this does for you is the hotter temperature makes the PLA become glossy. So I get a nicer looking finished product at the higher temperatures. Even if I was to print this at 3,600 millimeters per minute, I would keep that temperature at 226 because it will give me that glossy finish that I'm looking for. If you do it at 195, it's going to handle the filament, it's going to melt, and it's going to adhere, but you're not going to get the gloss out of it. Okay, now let's go on to cooling. I just set my first layer fan speed to 40%. And when we get over to the G code, this is just the stuff that defines my particular printer, so sizes and all of that. For scripts, my starting script is a G28 that homes all the axes. And all these other scripts in here, except for the ending script, have nothing in them. My tool change is empty. My ending script has some parameters in it to turn everything off when it's done. We covered the other section. That's my section there. And then for advanced, we have a couple of interesting things if we're going to do two-color print. We have a starting print height and a stop printing height. And we're going to use that today. But first of all, we need to know exactly where we want this two-color print to start. And to do that, I'm going to go up here and view the cross-section. And I'm going to start bumping up the z-axis here. And once I have found a point where the base layer is complete and the next layer, the arrow in this case, is going to start, I'm at about 2.1 millimeters, maybe 2.2. If you're using a 3/10 of a millimeter height, then you probably want to use 2.1 millimeters as the settings that we're going to use next. So now that we know that, we'll go over back to our settings and we'll go to Advanced, and we're going to do Start Printing at 0, but we're going to stop at 2.1 millimeters. Whoops, I'm sorry, I didn't mean to. Now I got to go back and do that again. Okay, and let's OK that so it saves it. Okay, now we have our base layer taken care of. Now we're going to add another layer, and this is going to be a copy of the first layer, and we're going to call this second color. And okay, so now what I want to do here is go back to the Advanced tab, and now I want this one to start printing at 2.10 millimeters, and I'm not going to have a stop printing height. I'm going to let it complete. But here's the important thing I need to do next. I need to go over to this extruder on the second layer and tell it that it is tool number 1. And the reason for that is because I want to go into my scripts over here, and I want to add something in the tool change script. And that's something that I want to add is a command called M600. And this is a filament change command that is used in Repetier and also in Marlin firmware. What the M600 does is it stops the printing, moves the printer head out of the way, it extracts or retracts, I should say. It retracts the filament so that you can take it out, and then you change filament, and then you can use the knob on your LCD display to move, get some of the filament to run out till your color change is good. And then you just press on that knob on your LCD display, and it will resume, put the print head back where it came from, and resume printing from there with the second color. This is pretty cool stuff. So we only do this tool change on the second color layer, and we have to change the extruder to be a different tool name so that it knows that we're changing tools and it knows to execute this M600 command. Okay. So now we've got pretty much everything set up that we need. Let's go ahead and prepare to print. I want to select both layers because we're going to print this entire thing in one shot. And this is going to be continuous layer by layer printing. And you can see here, this is what the final result is going to be. I don't really like this little space in here, but yeah, I'm not going to mess with that right now because I really just want to show you how to do the 3D printing. When we look at the final printed object, you're probably going to see a little bit of a part in here that I don't really want, but neither here nor there. Anyhow, let's go ahead and save this out. And I'm going to save this out to my desktop. And then I want to go in and I want to show you the G code that got produced by this. So this is my G code, and I'm going to look for that M600 command. And there it is. So we're at Z height of 2.4, which is just a little bit above the 2.1. So 2.1 is the base start. We add 3/10 to it because that's the filament height that we have. And we're at 2.4 on the Z-axis to start doing a filament laydown of a second color. When the 3D printer hits this M600 command, it's going to eject the filament. It's going to move the print head out of the way before it does that. It's going to allow us to insert new filament and clear the nozzle of the old color. And then when we press on the knob, it's going to allow us to put the 3D printer head back where it started from and continue printing. So that is what we need to do. The next step I'm going to go ahead and do is we're going to bring up the repetier host, and I'm going to turn on the heat bed to 60 degrees. I'm going to change my my temperature here to 226 degrees for my extruder, and we'll let the bed start coming up to temperature. And once that reaches temperature, then we're going to zero out our Z-axis and get it ready to start printing. So I'm going to pause for a moment while everything comes up to temperature, just to show you here. This is what my display looks like, and as you can see, we're 36 degrees now, and we're trying to get to 60, and we're at 79 degrees on the extruder, trying to get to 226. And so at this point we're going to pause, and I believe that is a command shift. Alright, our bed temperature has now reached its optimum. We're at 60 degrees on our bed and 228 roughly on our extruder, and now it's time to go ahead and zero out our Z-axis. And to do that, I'm going to have to switch over to my print panel, and let's move some things around a bit. Let's put this over here so I can continue to do this. I'm going to go ahead and zero the Z-axis. I'm pretty sure this is not going to be zeroed right now. So we're up to temperature, and what I'm going to do. Oh well, this is pretty much right on. This is pretty much right on. I'm pretty much happy with that. I like that. If I needed to adjust my setting, what I would be doing here is turning this adjustment screw probably about 1/4 of a turn. It's usually all it needs. The reason this was adjusted properly is because I had zeroed it earlier, and then I went in to the print settings and I actually bumped up the Z-axis about 3/10 of a millimeter while the unit was cold. So that is just about how much those springs expanded when we went from room temperature to 60 degrees C. So now we are just about ready to start printing. I'm going to have to cover this up for a moment to hit the run button. Let's go ahead and do that. Did I do it? No, let's do it. Well, oh, we got to look the G code. Oh, minor little problem here. Okay, there we go. There's our part. Now we're ready to run. So there we go. Let me get back to this. Now one thing S3D is doing is it has slowed down the printing a little bit because it knows it's doing these circles, and it can slow it down on its own. This can go quite a bit faster. We're on the first layer, which is 0.3 millimeters at the moment. Now that we're at the second layer, we're going at full speed, 100% at 7,200 millimeters per minute. And we're at 0.6 of a millimeter at the moment. All right, we're on the third layer at 0.9 millimeters on the z-axis. And remember, we've got to go to 2.4 for a color change. We're at 1.2 now. And now we're doing that infill part, which is the this crosshatch pattern, if you will. We're at 1.5 millimeters now. We're doing the outer edges. And we're actually starting into what's called the top 3 layers. So we only did 1 layer of infill with the crosshatch pattern. We're now at 1.8 millimeters. And again, the part that we're reproducing is this disc that we have on the z-axis. We're now at 2.1 millimeters. This is getting very close to approaching our point where we're going to be doing a color change. When it finishes this layer is when we're going to get the tool change code executed, and it's going to execute the M600 command, which is going to allow us to retract that filament and put a new color in place, and then resume printing from there. And you just heard it happen. And it just extracted the, retracted rather, the filament. So this is my old filament. What I'm going to do is cut that end off. And we're going to get out some white filament because that's just what I have loaded up here. And we'll clip the end of the filament at an angle. I don't know if you can see that in there, but that's a nice 45-degree angle. And then we're going to attempt to straighten out the filament as best we can and reinsert it into here. And then we're going to start, let me show you here the display. The display is telling us to change filament, rotate to move. So all I'm going to do is start rotating the knob here. And what that's going to do is it's going to allow us to get rid of some of this old color that we had in here. And I'm just going to grab some tweezers and pull that out, rotate it some more, make sure we got a nice bit of white flowing through the extruder, because that's our new color. We were doing some red, and it's still oozing out. So I'm going to kind of wait for that to stop oozing. That looks good. And now I am ready to press the knob and resume printing. So here we go. And I'm going to go ahead and grab that last little bit of material. So as you can see, we have affected a color change. We're now printing with our second color. And so this arrow component of that part is now being printed. And if you really want to see the difference that 7,200 millimeters per minute makes on your speed, you need to do that with a much larger part than this one that I'm doing here. If you're doing a large part, this print head will get up to speed, and you won't have. Okay, so we're done here. Boy, we're really we had some excess plastic come out of there. Okay, there's our part. And let me go over here and move the, whoa, let's go back. Alright, let's get the phone back up here. Okay, there was a little glob of plastic here. I'm going to have to file that off. I don't know why that took place, but it seems like I've never used this white filament like this. This is kind of why I keep tweezers around. And so while we're talking about tweezers, let's talk about the rest of the tools that I have. This is just a, you know, a tool to do the socket heads. It's a 2.5 millimeter hex tool. This is a tool that I'm going to use to get components off of the bed once it's cooled. And this tool here, which is an X-Acto knife, it's with a flat blade on it. And I really like using this tool because it's flexible. This bends, and it's got a nice taper on it, so I can get that underneath the part. And all you need to do is break the adhesion. And once you've broken the adhesion, the part will pop right off of there. But you have to wait till it cools. And so right now we're at 54, and we got to get down to about 25 or 30 degrees C before we pull this part off of the bed. So at this point, I'm just going to pause the presentation. All right, we're resuming from where we left off. The temperature has dropped down a little bit. We're now at 43 degrees, which is not ideal. I'd rather have a little cooler, but I'm going to go ahead. I know that I can remove the part at this temperature. And so what I'm doing is using this little flat-bladed tool to get in here just a tiny little bit. And if you noticed right then, the adhesion broke free, and this part is now free. Okay, and this is because of this PEI bed that I'm using. This is wonderful stuff. If you do nothing more than your 3D printer, do yourself a favor and make yourself order yourself a sheet of this PEI and put it on your 3D printer's bed. Let's take a look at this part. This is you might try to let you see the gloss that the temperature of 226 degrees with PLA gives you a lot bigger, a lot glossier finish. And this is our two-color part here. This could have been a little better quality if I'd have slowed it down, and if I'd have done it at 0.2 of a millimeter layer height. But this is not bad for this piece of material that we're using for what we're making out of it. It's just fine. And it illustrated the purpose that I needed to make, and that is how to do two-color printing with Simplify 3D. And I hope you enjoyed this presentation. And with that, I'm going to stop the video. I think, maybe. Let's go here to